In this video, I'm going to review how to solve and graph absolute value inequalities. So when we graph and solve absolute value inequalities, we're still going to have two cases, but you're going to have to use a keyword when you write your solution. The two keywords are and or. Now, depending on what kind of comparison symbol you have, that will dictate what kind of symbol you use. So let's solve this first example. It says the absolute value of 4x minus 8 minus 5 is less than 11. Now, anytime you have the symbol less than, so less than, think less than. So it sounds like and. So when you have the less than symbol, you're going to use the keyword and. So now let's solve this one. First thing we need to do is get our absolute value by itself. So I'm going to add 5 to both sides. And now I have the absolute value of 4x minus 8 is less than 16. Now there are two ways of simplifying this one with a less than sign. You can either use the keyword and, or you could write it in a simplified form. I'll show you in both ways, and then you get to decide which method you'd want to solve. So the first one I'm going to solve is using the keyword and. So I'm going to take 4x minus 8, so the expression in the absolute value has to be less than 16. So that's case 1. And then case 2 is going to be the expression 4x minus 8. And now we have to do the opposite. So instead of less than, it's going to be greater than. And when we change the sign, we're going to also use the negative form of 16, which would be a negative 16. So with inequalities, anytime you divide or multiply by a negative number, you always flip the symbol. Since I'm making the number negative, I'm really multiplying it by a negative, so I'm flipping the symbol. Now we can solve for x. So I'm going to add 8 to both sides, and I'm left with 4x is less than 16 plus 8 is 24. Get x by itself, I'm going to divide by 4, and x would be less than 6. And, gotta make sure we put our keyword in there, and then we solve the other side. So I'm going to add 8 to both sides, and this is going to give us 4x is greater than negative 8. To get x by itself, I'm going to divide by 2, and I'm going to have x is greater than negative 4. So that is one way we can solve it. The other way would be to do a simplified form. So I'm going to put the expression and the absolute value in the middle. So I have 4x minus 8. We know it has to be less than 16, and it's going to be greater than negative 16. Now I know I wrote that less than symbol here, but if I'm reading it from the right side, 4x minus 8 is greater than negative 16. Now I can just simplify by adding 8 to all the sides. And this is going to give us 4x in the middle is less than 24 on the right side, but greater than negative 8 on the left side. And the last step is divide by 4 on both sides. And I would have an answer of x is less than 6, but greater than negative 2. And I noticed that on the previous problem, I divided it by 2. I should have divided this by 4, which will make this a negative 2. So I have two ways of writing it. It's up to you which one you want to do. I usually prefer the one on the right, but that's my preference. Now to graph it, going to put our numbers on the side. So I have negative 2 on the left. I got 6 on the right. And if I were to find out how far apart the numbers are, they are 8 apart. Half of 8 is 4. So if I take 6 minus 4, that gives me a positive 2. So 2 is halfway between -2 and 6. So now I can put my circles on. Because it's just less than, it cannot equal those numbers. So I know it's an open circle on -2, but it's got to be greater than -2. It's an open circle on 6 because it cannot equal 6. It's got to be less than 6. So it's any number between -2 and 6, but they cannot include those two numbers. So that would be our solution and solution graphed. Next example. We have 3 times the absolute value of x plus 7 minus 8 is less than or equal to -x minus 11. Now, since this one has less than, I know I'm going to be using the keyword and. And I can't write a simplified form of this because I have a variable on both sides. So I'm going to do 2 separate equations here. But the first thing I'm going to do is get the absolute value by itself. So I'm going to add 8 to both sides. And that's going to give us 3 times the absolute value of x plus 7 is less than or equal to -x minus 3. Now the next part, I'm going to get the absolute value by itself by dividing everything by 3. And I'm left with the absolute value of x plus 7 is less than or equal to a -1/3 x. Now -x divided by 3 is the same as -1/3 x minus 1. Now that I have the absolute value by itself, I can now do a case 1 and a case 2. So now case 1 and case 2, I'm going to have x plus 7 is less than or equal to, and it's just going to equal what I have currently, so -1/3 x minus 1. And I'm going to have x plus 7 is greater than or equal to the opposite. So the opposite of a -1/3 is a +1/3 x. And the opposite of a -1 is a +1. And now I can simplify each side. So I'm going to get my x's to the left. So the opposite of subtracting 1/3 x is adding 1/3 x. And then I don't want this 7 here, so I'm going to subtract 7. So right now I have 1x plus 1/3 x, which is going to give us 4/3 x is less than or equal to -1 times, or -1 minus 7 is -8. Now to get to the x by itself, I'm going to multiply by the reciprocal, which would give us 3/4. 3/4 times 4/3 is 12/12, or 1x. And whatever I do on one side, I must do on the other. So multiply that side by 3/4, and x is going to be less than or equal to -8 times 3 is -24. -24 divided by 4 is -6. And can't forget our keyword. Then we're going to do the same thing here. I'm going to get my x's to the left side. So I'm going to subtract 1/3 x. That means I don't want the 7 here, so I'm going to subtract 7. And that's going to give us 1 minus 1/3 is 2/3. X is greater than or equal to 1 minus 7 is -6. The opposite of multiplying by 2/3 is divide by 2/3 or multiply by 3/2. That gives us x is greater than or equal to, multiply this side by 3/2. -6 times 3 is -18. -18 divided by 2 is -9. So now that we have our solutions, we can now graph it on a number line. And I'm going to have -9. And I'm going to have -8, -7, and -6. Now, since this has the equal to part, it can equal our solutions. So I'm going to have a filled in circle at -9, a filled in circle at -6. Now it says it has to be less than -6. So less than means it goes to the left. And it has to be greater than or equal to -9, which means it's got to go to the right of -9. So every solution in between and including -9 and -6. And our last example, solve and graph this absolute value inequality. Here this is a greater than symbol, so we're going to use the keyword or. So one way to think about it is when you say greater, you hear the word or in it. So greater, greater, use the keyword or. So we're going to get the absolute value by itself. So I'm going to subtract 5 first. And that's going to leave us with the absolute value of 6x plus 3 divided by 2 is greater than or equal to 14 minus 5 is 9. Now the opposite of dividing by 2 is multiplying by 2. So the 2's divide out, multiply 2 on the right, and I'm left with the absolute value of 6x plus 3 is greater than or equal to 18. Now since I have the absolute value by itself, I can now rewrite this with two cases. Case 1 is going to be 6x plus 3 is greater than or equal to 18, or case 2 would be 6x plus 3 is less than or equal to, since I flipped the symbol, I changed the sign, so instead of a positive 18, it's a negative 18. And now I can simplify. So I'm going to get the x by itself by subtracting 3. And I have 6x is greater than or equal to 15. To get x by itself, I'm going to divide by 6. And now I have x is greater than or equal to 15. 6 simplified as a fraction would give us 5 halves. 5 halves is 2.5. Or on this side, subtract 3. And that gives us 6x is less than or equal to a negative 21. Divide everything by 6. And I'm left with x is less than or equal to negative 21 divided by 6 would be the same thing as saying negative 7 halves or negative 3.5. So now we can graph our solutions. So I'm going to have a negative 3.5 here. I'm going to have 2.5 here. I could go 1.5, negative 1.5, negative 2.5. And since I have the equal to parts, they're going to be filled in circles. So a filled in circle at 2.5 and negative 3.5. But it's got to be greater than 2.5, greater than or equal to, so greater than means goes to the right. Less than or equal to negative 3.5, less than goes to the left. So you can see there's a gap because it's either going to be one or the other. There's nothing in common. So that is how you can solve and graph absolute value inequalities.